Okay, so we're going to start talking about the graphs of logarithmic functions. To start this off, we're going to look at an exponential function. Whoops. And so I'm going to have f of x equals 2 to the x. That's my favorite logarithmic function, or exponential function. So we know it goes through 0, 1. We know it goes through 0, 1. It goes through 1, 2. It goes through 2, 4. And then it's getting closer to 0 as the exponents get negative, as x gets negative. And so it looks something like that. There's an asymptote at the x-axis. Now let's go to a logarithmic function. So remember, if we wanted to change this to a logarithmic function, we would have y equals 2 to the x, but switch the x and y. And now write that as log base 2 of x equals y. Okay, so taking this, we're doing an inverse here. Okay, a logarithmic function and an exponential function with the right, numbers and arguments and things like that are inverses of each other. Okay, so I'm going to write that then as g of x is equal to log base 2 of x. So remember back when we did the exponential function, we had like a little table of values. I didn't write it out. But we were saying like, okay, if you put in a -1, you get 1/2. If you put in 0, you get 1. If you put in 1, you get 2. If you put in 2, you get 4. We had something like that. Well, now for the inverse, we can switch the x and y. So xg of x, we would have 1/2, -1, 1, 0, 2, 1, and 4, 2. So then let's see what that looks like. So this first point, 1/2, -1, I'm going over a half and down, you can see it, down 1. 1, 0 would be right here, and then 2, 1 would be right there, and then 4, 2, let's see, 4, 2 would be right there. And so you get this shape like this. Now remember the thing about the diagonal and that an inverse, when they graph two functions that are inverses, you fold on the diagonal and the points line up, right? Okay, so that holds true for these functions. Okay, let's see, anything else I want to say on that? How do you get that function? I mean, let's say you didn't want to graph the exponential function. You can go from the right there where you have the exponential form with y in the exponent, and then you would choose y values and calculate the x values. So usually if we have to graph a logarithmic function, I'll show that on another example. That's what we do. We write it in exponential form, but we choose y values and then calculate the x values. Okay, so what happens on the domain and range? Well, for the exponential function, so for f of x, the domain was all real numbers, right? Oops. Domain was all real numbers, and the range was 0 to infinity. So in the inverse, g of x, so this one, and you can tell from the picture as well, but the domain is going to be 0 to infinity, and the range is going to be all real numbers. So you're switching the domain and range. But look at our graph here. We don't have, for the green curve here, the logarithmic function, this is g of x, we don't have anything going past the y-axis, right? So we have from 0 to infinity for the domain, and then what about the range? Well, we're going off to -infinity that way as we get closer to 0 from the right side, and we're going off to infinity this way as we're getting closer to positive infinity. Okay, so that's how the domain and the range work out there. All right, a couple characteristics. We talked about most of them. By the way, and we're just talking now about the logarithmic function. Okay, so characteristics of g of x equals log base b of x. We'll just do it in general terms. Now remember, if the base changes, this time we had a base of 2 in our example, but if the base changes to 3, that's going to change the shape of things. Or if it changes to 5 or 10 or something like that, it's going to change that shape, but the characteristics are going to hold, okay? So this is now for just kind of a general log some base b of x. Okay, it is a one-to-one function. So if you look at that, you know, as you're getting closer to 0 from the right, it's approaching the y-axis, but it is still a one-to-one function. We told you about the domain. The domain was from 0 to infinity. And what else? Oh, and the range, we talked about that. The range was negative infinity to infinity. And now we're going to talk about some points on the graph. So right here you have a point, it's an x-intercept. The x-intercept is going to be b, comma, I'm sorry, I did that wrong. It's going to be 1, 0, right? So think back to your y-intercept here. You know, your y-intercept here was 0, 1. So your x-intercept is for the logarithmic function is going to be 1, 0. Okay? We also have a key point. So they call it that in the book. So I wanted to mention that because they don't really explain what that means. The key point is when your exponent is 1. And so if you have, you know, 1 being the exponent, you're just going to get b. Okay? So then the key point is going to be b, comma, 1. Like in our example, it was 2, comma, 1. So and that point was right there. Okay? So, but if b were 3, it'd be 3, comma, 1. Or if it were 5, it'd be 5, comma, 1. But that's what they're talking about for the key point. The function is increasing. It's an increasing function. So if you think about the outputs getting larger and larger as you go from, you know, a low number to a higher number. Okay, and then there is no y-intercept. No y-intercept. Forgot to mention that. So it's not crossing the y-axis. And then what happens if we had the base being like a fraction? Okay? So what happens if you had, in your original function, you had something like this, maybe, you know, f of x being 1/2 to the power of x. What happens when we switch that around and say g of x is going to equal log, the base is 1/2, right, of x, something like that. Well, then it's going to look different. You're still going to have your key points here, b1, so that in this case it'd be 1/2, comma, 1. So think about just going over 1/2 and up to 1. So something like there. And then you're still going to have your intercept at 1, 0. Okay. But your function's going to go like this. You'd have to get more points, you know, to draw it nicely. But it's going to be decreasing. The the domain's staying the same, the range is staying the same. Oh, I didn't talk about the asymptotes. Well, one asymptote, and the asymptote is going to be the y-axis here. So asymptote x equals 0. That's a vertical asymptote, by the way, and so it's x equals 0. And it's the same on the other graph that we have. So asymptote here is also x equals 0. Okay, so I think we talked about all the characteristics for this, and we'll leave it at that.